This is the third video in a series of videos on equilibrium calculations. So we're going to be doing a difficult ice table in this video, which is going to require a significant amount of math that we haven't had to use yet in this course. So if any of this math we're about to do seems unfamiliar or like it's been quite a long time for you, this would be a great time to schedule a visit for the Center for Academic Success right now, nice and early, a few weeks before we ever get tested or quizzed on this material. Okay, so this example says at 1280 degrees Celsius, which is very high, by the way, we know the equilibrium constant for this reaction, 1.1 times 10 to the negative third. Here is our reaction. Bromine, 2 bromines goes to 2 individual bromine atoms. And we were given a couple of initial concentrations, 0.063 for Br2, 0.012 for Br, and we want to find the equilibrium concentrations. So we can see that this already looks different than the last example we did. First of all, we're given the equilibrium constant, and in the last one, that's the number we were solving for. But more importantly, the only concentrations that we're given are initial concentrations. We don't have any of the equilibrium concentrations, so we're not going to be able to easily solve for the change like we did in the last one. So let's go ahead with our 4 steps again, and just keep in mind that things are going to look a little bit different. So our first step is to determine the shift direction by solving for Q. So Q is going to be products over reactants. So our product is Br, and there's 2 of them, so it's going to be squared, and it's the initial concentration because we're solving for Q. And our reactant is going to be Br2 initial, and there's just 1 of those. Okay, so now we're going to solve for the number for Q. So our initial concentration for Br, 0.012 to the second, and for the Br2 is 0.063. Got to be careful with these reactions where the different compounds look very much the same. Got to be very careful not to mix those up because they make a pretty big difference. Okay, so math happens here, and your calculator, you should get 2.29 times 10 to the negative third for our Q, and we can look up our K in the problem that was given. It was 1.1 times 10 to the negative third. So we need to figure out which one of these numbers is the larger one. It can be a little bit hard to tell when they're written in scientific notation, so you may need to brush up on that. But these very, very small numbers, this one is going to be closer to 0 than this one. So this is going to be the smaller one. So Q is going to be greater than K. And if we draw the balance beam with K in the center, if Q is greater than K, we draw it on this side. And there's going to be a shift to the left. You may ask yourself, is Rachel going to draw the balance beam every time? And the answer is yes. I will try and draw the balance beam every time because I think it's the clearest way to remember to do that shift. Okay. Step 2 is to fill in an ice table. So here's our ice table. On the left, our reaction goes along the top. Br2 gas goes to Br gas. We'll divide the reactants and the products, and we'll divide C from E to remember to add them up. All right, so let's see what we've got. We have the Br2 initial value, 0.063 molar, and we have a Br initial value, 0.012 molar. And just because I know this is going to come up, even though there is a 2 in front of the Br, we don't multiply this initial concentration by anything. This concentration that we were given includes the 2 inside of it. So we don't have to change these numbers at all when we plug them into the table. So next we're going to do our change, and that comes from the shift. So we're shifting towards the left. So our products are decreasing and our reactants are increasing. And we don't know how much, we weren't given any information, so we will just say X and 2X. And then we don't have any information about the equilibrium in this case either. We need to find those numbers. So since we can't fill anything in, we'll just go ahead and add I plus C to equal E. So 0.063 plus X over here, and 0.012 minus 2X over here. And everything in this table is in terms of molarity. We're using concentrations in this table because we're looking at the initial concentration, the change in the concentration, and the equilibrium concentration. Okay, third step is to solve for X using K. So I'm going to write KEQ. This is another way to write it for K at equilibrium. That number is going to be BR squared over the BR2 to the first. And we're going to plug in the numbers from the equilibrium column into the equilibrium constant. So for BR, that's our product, 0.012 minus 2X, and that whole thing is going to be squared. And then for BR2, 0.063 plus X. And then we can put our KEQ over here, 1.1 times 10 to the negative third. And this is the part where we wrote math happens in the last video. We are actually going to do the math one time all the way through to make sure we're all on the same page. So this is our math problem here that we have to do to solve for X. And so the first thing we do is we always try and get all of the X's gathered onto one side. So we can pretend that this number is over 1, and then we can cross multiply. Okay, so we're going to cross multiply to get rid of the denominators. And we are going to have 0.012 minus 2X quantity squared times 1 equals 1.1 times 10 to the negative third times 0.063 plus X. Okay, so now there's no denominator, but now we need to multiply this exponent through. And so that is called foiling. It stands for front, outside, inside, and last. Again, if that doesn't sound familiar, pay a visit to the Center for Academic Success. They would love to show you how to do algebra. And this is going to reduce to 4x squared minus 0.048x plus 1.44 times 10 to the negative fourth. Put that in parentheses so you can tell that that goes together on the left side. And then we want to multiply through here on the right side as well. 6.93 times 10 to the negative fifth plus 1.1 times 10 to the negative third times x. You can choose to use scientific notation or to write the decimals all the way out. Either is fine. Just make sure you keep the correct number of significant figures. Okay, so now we are going to collect like terms. We're going to collect all the x squared terms together, all the x terms together, and all the terms without an x together. So we've only got one term with an x squared, and that's the 4. There's 2 terms with an x, so we can bring those together to get 0.0491 x. And then there are 2 terms that don't have an x. We can bring those together, 7.47 times 10 to the negative fifth. And I move them all onto the left side so that the right side equals 0. And this is probably starting to look familiar to you. You've probably seen equations like this in high school, and you know what's coming. It's the quadratic equation. Cue dramatic music here. So the quadratic equation is no one's favorite thing, but what it's really good at doing is solving for x when you have an x squared as the highest exponent in your equation. So hopefully you know the song that helps you remember the equation. X equals the opposite of b, plus or minus square root b squared minus 4ac all over 2a. And by a, b, and c, we mean the coefficients in front of the x squared, the x to the first, and the x to the 0. Okay, so you will need to complete the quadratic equation to solve for x, but since we're here and we're together on video, I thought I would show you how to use your graphing calculator to do this instead. So you may not all have the same kind of calculator as me. I've got a TA84 Silver Plus, but many of your calculators will come with a loaded apps menu. And if you have a loaded apps menu, you might have my favorite app. It starts with P, so I'm going to skip to the P part of the list, and that app is called PolySimult, your new favorite friend for quadratic equations. So if we press enter, we can open the Poly Root Finder app. There's a couple of different programs in here. We want to use number 1, the Poly Root Finder, because we're trying to find the root of our equation. So the first thing we need to put in is the degree of the polynomial. So that's the highest power of our x. So our highest power of x is 2, because we're solving an x squared problem. You can also do larger root finders with this tool. So we'll press enter, and then it's going to take us to a screen to enter the coefficients. So here they've used A2, A1, and A0. We used A, B, and C, but you want to enter them in that same order. All right, let's see. So our x squared coefficient was 4. Our x coefficient was negative 0.0491. And make sure you include the negative because that is definitely absolutely important to solving this. And then our x to the 0 coefficient was 7.47 e to the negative 5. And you can enter these as decimals or as scientific notations. Okay, and so then each of these buttons at the top is going to take me to a different menu. So I want to hit solve. So I'm going to hit the button on the end. And this program has just solved the quadratic equation and found both of these answers for you. So if you're a list person, you can use this store as x button to store these x values as a list so that you can use them for calculations later. If you don't know how to do lists, don't worry about it. And if you want to go back to the coefficients page and do it again, you can hit the button under coefficients. And if you're finished, you can hit the button under main to go back to the main menu and quit. So that is how to use your calculator 101. You are welcome. Here's the summary of what we just did on the calculator. You go to the apps menu. You open the app called PolySimult if you have it. If you don't have it, you will have to solve this yourself. And then within that app, you're going to use the function called the Poly Root Finder. And then you're going to enter your degree equals 2 and your coefficients. Okay. So math happens here. Either you doing it on your calculator or you doing it by hand, one of those two ways. And you are going to solve for x. And remember that because it is x to the second, there are going to be 2 answers for x at the end of the problem. So according to my calculator, one of those is going to be 0.00178, and one of them is going to be 0.0105. Okay, 0.00178, and all of these are in molarity. Or the other value for x, 0.01050. Molarity. Okay, so we've got 2, but we know there can only be one true value. Insert Lord of the Rings reference here, because we know that there's only one equilibrium concentration for each of these. There are not two concentrations for each compound. There's only one concentration for each. So only one of these values can be a realistic correct value. So as we move on to step 4, we have to figure out which one of those it is. So step 4 is answer the question. Question wants to know, what are the equilibrium concentrations? So they want to know about these things in the E row. So we can find concentration of Br2 at equilibrium and concentration of Br at equilibrium. But we don't know which value for X is the correct one, so at the beginning we need to use both of them until we can eliminate one. So this is our value for Br2 at equilibrium. It's 0.063 plus X. So we'll need to plug in both the values to see which one is going to make sense. So if we plug in X1, the 0.0078, we're going to get 0.065 molar. And if we plug in X2, 0.0105, we are going to get 0.073 molar. Okay, and as of right now, both of those are normal looking, positive, small numbers, so I could be happy with each of them. So let's try finding the other one and see if that one tells us which X is the correct one to use. So Br at equilibrium is this one, 0.012 minus 2X. So if we use X1, that will give us 0.008 molar. And if we use X2 and plug it in, that's going to give us negative 0.009 molar. And that is going to be a problem. Concentrations cannot be negative. You cannot have -2 of something in 1 liter of solution. So they cannot be less than 0. So that means that if this value for X2 gives us a negative concentration, that we are not going to use that value for X2. We're going to cross it out and we are going to choose X1 as the true and correct value. And so these are going to be our correct answers. 0.065 molar for Br2 and 0.008 molar for Br at equilibrium. So as you will see, there is a pretty significant amount of math that is required in solving this, but you can save yourself a lot of work by using that app on your calculator or on your friend's calculator. So that's a good thing for you to use. So we're going to do another example in the next video, and this time I'm going to show you another way to save yourself some work, an assumption we can make to shorten the calculation.